Today we are joined by Nick, who is the co-founder and CTO of Cohere, that provides a ton of cutting-edge NLP models for a wide variety of use cases, from like embeddings to summarization to generation, and are really one of the pioneers in this space. And prior to that, Nick was one of the first hires at the Google Brain team in Toronto with Jeff Hinton, and worked on Capsule Networks, adversarial examples, and a lot of like interesting research areas there. Welcome, Nick. Yeah.
Cool. Thank you. Yeah, thanks for having me. Great to be here.
Yeah. So to get started, I would love to hear more about like how did your journey into ML start?
Yeah. When I was in high school, I really liked programming and was interested in AI stuff. ML, I didn't know about ML at the time, and ML wasn't really anywhere near as well studied. But I went to U of T, and then I started taking cognitive science courses. And it was actually in a cognitive science course that I was first introduced to neural networks. And that was my introduction to machine learning. So I actually, like when I first started thinking about machine learning, it was only neural nets. It was only later that I learned that there was machine learning that wasn't neural nets, which is kind of funny. Yeah, I was introduced via a cognitive science. John Vervaeke at U of T is a cognitive scientist, and it was him who introduced me.
That's awesome. And it's kind of like, it's fascinating how the trend has become all neural networks now.
Yeah.
You were kind of ahead of the curve. Awesome. Like, so you obviously started a company in the NLP space. What about like language AI like excites you today? Like, why are you so bullish on the space that you kind of like created this amazing company in the space?
Yeah, I think language is a really great area for machine learning and transformers. And I think that for a number of reasons. One of them is that it's a modality that's, it's our primary modality, right? Like it's the way people solve the most problems. Like language is arguably our best technology, and it's the thing we use to solve the most problems. The other is that it turns out transformers work really well at it. And it turns out that a single transformer trained on the biggest data set possible is really good at a whole bunch of separate tasks. Like that's kind of interesting. And I don't know if that's true for many other modalities. And by that, I mean, like, 100 billion parameter language model is probably better at 10 separate tasks than 10 billion parameter models for those specific tasks. And that's like an interesting discovery. It wasn't obvious to me at the beginning of starting down neural nets that you'd have this thing that if you just scale it up and throw better data at it, you'd end up with better results. So that means it's a really great place to apply to start a company whose objective is only to make these models useful and accessible and safe to people.
Awesome. Just to double click on that one, like why are transformers so effective at language?
Yeah. Why is a good question. There's maybe a few reasons. So you mentioned that I did work originally on Capsule Networks, and I think there's some really nice similarities between Capsule Networks and transformers. Like I kind of think transformers are take the best of Capsule Networks, and that is coincidence detection and looking for agreement between predictions. Like that's really what transformers are doing. And they model sequences with a correct attention mask that way, and then they look for agreement between the predictions and the tokens of that sequence. So I think that's a really good prior for language, but that's not it alone. Like I think another of the big reasons for why transformers are good at this is that they're really easy to scale. And that's just a property of the net itself. Like Capsule Networks never really scaled because the procedures that we had in them, like iterative routing and it was just really hard to get that to work on anything big. It took up a lot of memory. It was not fast. It wasn't well implemented on the hardware, and so they could never really scale. Whereas transformers are super easy to scale. And so they have these nice priors, and then they can also be done massively, and that's pretty great.
Yeah, no, I think that's fascinating. In some sense, like I worked on the TPU team for many years, and it was fascinating how the architectures became more conducive to the hardware that was available. So that's like a fascinating observation.
Yeah, well, that's a super, that's a super interesting point. Like I think in like 100 years or something, there will be really interesting books written about the parallel development of computer hardware and neural nets and when they influenced each other. And like, yeah, whether or not are we stuck in some local, like, are we, are the nets we're training now, are they the right priors to be building into the nets, or are they just the things that happen to work with the hardware we have access to? Yeah, and I don't know now. I don't know, and maybe in like 50 years we will know, but that'd be interesting.
Yeah. Awesome. One thing I did want to flag is, like, I think your video is frozen for some reason.
Oh, is it? Oh, yeah. Sorry. Thank you. Sorry, I don't normally use Zoom.
Okay,
is it better now?
Yeah.
I just stopped and, okay, weird. Yeah, I just stopped and started it and now it worked. Cool, thank you.
No worries. Awesome. So you touched a bit about this, like just being able to scale these large models has been like super effective. And we've kind of seen this like exponential compounding in like number of parameters and the data sets used. Like, how do you continue doing that for like 5 more years? Like how do you think about like access to larger and larger data sets? Like, will that become a bottleneck?
I don't think access to larger data sets is a bottleneck. I think access to good data sets might be a bottleneck. Like, I think access to, text, it's one thing to, there's enough text on the web. Like that, there's enough text that people have put freely available to crawlers, so that you can create a data set of like arbitrary size. Now, there's a lot of stuff in there that you don't want to train on. And some of that is because it's not high quality. Some of that is because it's like not the type of stuff you want your model to be able to generate. Like, we do a lot of filtration for safety and things like that. Some of it is because it's actually not human readable text. And we found, like, when we were creating our data set, we found something that was like a gig file of just random characters that for some reason somebody was hosting on the web that our model, so I think finding good ones might be challenging, but even there, I don't think the bottleneck is going to be on data. I think the bottleneck is on compute for training, on scale, on things like that. We seem to be able to get enough data, although actually, wait, I mean that, things have, in the past like year, I think things have changed. Now there's maybe some more implications that you should only ever do one epoch and that you actually need much more data than we have. But I think it's out there. I think we just have to do a better job of finding and curating it.
Okay, that's a fascinating take, because it's like most people who, when they think about starting training these models, think about like using Common Crawl or like Wikipedia dumps. And those are like, but as we start thinking about like what data is safe, could you touch a bit upon like, as at Cohere, like how have you started thinking about like safety, and like what are like some like technical challenges that you've run into and solved there around
for sure
safety of data sets, I guess?
Yeah, for sure. So we've been thinking about that right from the get-go, and that's because there's been a lot of great work that was done outside Cohere and other places on pointing out the limitations and the flaws of language models. Language models are a really powerful technology. They're really great at lots of things. That means they can be used to solve all kinds of super important problems. And that means that they also can be used for bad things. And they're not without risks. So based on some of the previous work that was done that has influenced our thinking, we've really thought a lot about like, what are the things we want to make our models bad at? Like, we're the creator of a tool. We want to make that tool really good for things we're proud of and really bad at things we would not be proud of. So we've identified that as like the two main threats that we think about are in generative models, at least, is the generation of identity-based hate and like astroturfing. Those are two things that a language model could do that as a builder of a language model, I don't want it to do. And so we've done a fair bit on trying to filter the data set so that it just doesn't see examples of that, and then makes it a poor tool for those applications. So some of those have been really simple, like word level filtrations, domain level filtrations. Some of those have been more complicated, like we published a paper a while ago where we used previous versions of the model to calculate the conditional probability of phrases. And then if that conditional probability for a document was high, we would throw that document away. And that saw some improvement, but that work is ongoing. Like I think we'll be working on that forever. Like I think as we continue to build better models, we'll continue to identify like ways that we can make them better aligned to the applications we want to support and worse aligned with the applications we don't want to support.
Interesting. So this reminds me of like one of the talks that you gave a while back, maybe like a few years back now, on like how adversarial examples are kind of like a loop with like, it's basically a chicken and egg problem where people like do innovation and then somebody comes up with like a new example and then we re-anchor to how do you solve for that? Like how has your thinking evolved from like that talk to today on this problem? Like
yeah, totally. Okay, so just to give a background to catch the listeners up on the adversarial example talk. So yeah, my main point, and I was not the only person who pointed this out. I did a bunch of work on adversarial examples, and at some point I realized like, hey, this is not a real problem. And the main issue there is when people study adversarial examples, mostly what they study is like, here's an image, and if I make some epsilon perturbation to that image, I can get it to be classified as something else. And that's certainly illuminating, like it tells you something about the way the nets are working, and that's to say we personified them as doing vision recognition the way we do vision. And that's obviously not true because you can make a tiny change that you can't see and yet the model thinks it's something else. So it's interesting in that it illuminates the way the neural nets are working, but it's not a security threat. It's not the case that like, if you wanted to trip up an image classification system, the easiest way to do that would be to make a small change and then see that it classifies. Like, if you want to trip up like the example that I forget who it was who came up with this, but it's like, if you want to trip up an autonomous car, you don't go and draw an epsilon perturbation on the stop sign, you just take the stop sign down. So there's lots of situations where that like robustness to sort of epsilon bounded, it's not really grounded in a real problem. Okay, that's my critique of adversarial examples in the images. Safety in language models, I don't think is like that at all. I think safety in language models is actually really well applied. And really well, like it is really grounded in real world risks. I think it's certainly worth looking at what people want to use language models for. And when we look at the types of stuff people put through our models and what they're doing with it, it's almost across the board fairly benign applications. Like what people really want to do with language models is things like entity extraction and like classification and error correction and things that are not. But there is the potential to misuse it and to do things that really do cause harm. So I think the work that's been done on safety and on alignment of large language models is like really well motivated. And I don't have that same criticism that I had for adversarial examples.
Yeah, that's interesting. And I guess like it's like in some sense it's a more bounded problem rather than like adversarial examples was like whatever you're tripping you could potentially like defeat any system potentially, but here it's like there's like a well reasoned of what is good, what is bad.
Yeah, I mean, I still think there will be the reason why I say this is a thing we'll be working on forever is that I think there'll be new people figure out, hey, you can use a language model for this nefarious thing, and we should probably avoid that. I think that will come up every now and again. And I think we'll always find ways of, hey, we can actually make it, slightly better at this, slightly worse at that. So I think that's going to be an ongoing process. And that's similar to adversarial example literature where people were constantly coming up with new defenses and new attacks. But this one I think is, really, really important to focus on and really well grounded.
One question to deep dive on like the technical side. It's like, let's say you had like some notion of how do you make the data set safe and you did like one run of the training. As you're starting to think about fine tuning, like your hypothesis on like what a safe data set looks like has evolved. So do you constantly like think of retraining from like scratch or? Like...
Yeah, well, actually the work that the paper that we talked about using that likelihood filtration, we did test out like, how much improvement do you get from taking a model and just fine tuning it on this new filtered data set. And it was like pretty much the same improvement. So we actually found that like you're just continuing to train on the old one was good. we do train new models every now and again. Like we make a, we change the tokenizer or something. We make some big change. We have to redo the whole thing. But we did find that you can have improvements from just fine tuning as well.
Oh, that's interesting. And like, tell me a bit about like what sort of like infrastructure are you running today around like crawling, data processing, like just on the pre-processing side of larger models? Like, do you mostly do that all in-house, things like that? Yeah.
We pull from a whole bunch of different sources. So we pull from all over the place. And that's because we try to just get as much as possible. And then we do all our own filtration on it afterwards for quality and safety. And I mean, even just, like our models currently are only graded for English. So even just to make sure that we're only reading English is another step in the filtration process.
What are like, how big is the engineering team at Cohere, and like, what are some interesting problems you're working on today?
Yeah, we're pretty large at this point. I think the engineering team is about 60 people, so we're pretty large. And that's because it turns out it's a very difficult problem to solve, and you need a lot of people working on it. What are some interesting problems? I mean, all over the space, we're pushing on embedding models and generation models. We shipped Codoc Classify recently, so now you can go into our platform and fine tune a classification model. And we're working on things like that, like figuring out how to apply these large language models to really well-formulated like problems that lots of people have, like entity extraction, summarization, really immediately applicable things. So we're working on that. We're working on scale still. We're working on safety. We're working on efficiency. Working on better fine tuning. The list goes on. There's so much work that needs to be done.
Yeah. So for anybody in the audience, if you want to work on cutting edge NLP, go check out jobs at Cohere. That might be one of the most fascinating places to go work on NLP at. Awesome. So one question I had is like, so there is like, you can train an off-the-shelf BERT model, like there are pre-trained models available. Like, what are some trade-offs that someone who's trying to like explore that option or like use the Cohere API like should be aware of? Like,
yeah, I mean, I'm a little biased here, but I think
I think the intent of the question is to like learn.
I really think so. I'm the CTO of Cohere currently, and in between like meetings and plannings, like what I do a lot of is I use our API. I use our product all the time. I build all kinds of weird things with it. And I do that one because I'm a skeptical person, and so it's nice to convince myself constantly that what we're building is useful. Also because I'm easily distracted, and it's nice to have a thing to like tinker with. But I have found that using an API for a language model as a developer is a really great experience. You can start with a really good model that's already bigger than something you would have access to as an individual or even as a well-resourced company. You can fine tune it on the data set that you have and get significantly better results than if you would take a small thing and fine tune it on that data from scratch. And then it's hosted and handled for you. And that's like as an ML engineer, like one of the things I hated the most was, getting GPUs and CUDA installed and like figuring out, is this server running the right version of this? And is that like, do I have the throughput enough for this thing? And if you're using an API, like a network-based API, you don't need to worry about any of that. So all the stuff that I build, I'm using the API, and it makes it so much easier. I can like have a hypothesis and be like, cool, I think I could do this with a language model. I can try it out in the playground, and if it works, I can really quickly go to production with it by just being like, well, cool, I never need to worry about hosting this or about like, how many copies of the model I have lying around, or if it's the right version or anything like that. So yeah,
I would 100% second that. Like, I think getting GPUs working with the Kubernetes was like one of my most nightmare projects.
Yeah, it's the worst. Yeah, and I never want to do it again, and so I never do. I think like one of the things we don't offer is if you want to like download a model and you want to take the first layer and you want to add in some like early or you want to change the loss function, or you want to add in an internal loss, like we don't give access to that level of we don't give that much into the model. So that's when like, downloading something from Hugging Face and trying it out yourself is the right place to go. But if you want to like solve a problem with a large language model and go to production, using our API is just going to be way easier.
Yeah, that's amazing. I think one, like, I lost my chain of thought. Yeah, I think the ease of like experimentation is huge. And then I think like you can very quickly measure ROI on like what impact you can have. Oh, and the other thing I was going to mention for people are like, if you're looking for like fun side projects that Nick has built, there's like an interesting blog post on building magic, like generating magic card, like Magic the Gathering, like newer cards in that, using a generation model, both like text and then like feeding that into like an image generation model.
Yeah, no, that was I think that's a really good example of like what I was talking about. Like that's, like, so Magic the Gathering is a card game. There's like 20,000 cards in it. I really like the game, but I wish there was more cards. So I used a Cohere model, fine-tuned it all in the cards, and then use an image model, and I can generate like a card for this game. But I put that online, like I made a website for it. It got to the front page of Hacker News, and I didn't need to worry about it was fine. It didn't go down. It had like the hug of death from Hacker News, but because it's just pinging these servers and they can scale as requests come in, it was fine, serving the whole time. So that was very fun. That website now, like we had an original peak, and that's when that blog post was released. But now it's actually back to peak usage again. It turns out that like, I think it's like 40% of users are weekly users, and of that, like 50% are daily. So it's a lot more engagement than I originally thought, but yeah, people are having fun with it.
For someone trying to create the next generation like Pokemon company that lasts like 20-30 years, this is your way to do it.
Oh, I would love it if somebody built a truly generative game, like card game with like, this thing is just, to make Magic cards. It's not a standalone game, but if somebody made a real generative card game where every card was unique and generated, that'd be so fun. I'd love that.
Yeah, 100%. So like, I think jumping topics a bit on like, what are some things that you think like, how should someone who's trying to stay ahead of the curve on NLP, like given the rapid progress in the field, like resources that you would rely on? Yeah.
Sorry, is this like an
advice question for people trying to learn or break into the field? Yeah.
This is maybe not a super satisfying answer, but I would say like I wouldn't worry too much about staying ahead of the field. Like I think as a researcher or as somebody interested in machine learning, you should just work on what is interesting to you. And that might be the big thing. That might be like something that everybody's excited about. It might be something that very few people are excited about. But I've been in ML long enough it's weird to say, but I've been in ML long enough to see a few hype cycles. Yes. Like to see, like, there was a while where GANs everybody was working on GANs. Suddenly everything was GANs. Everything was then adversarial examples. And then, now everything is diffusion models, and there was a while when everybody was talking about graph neural nets, like I said, but everything was RL. Like I've seen a few of these. And there's been great work in all of them, but it's just, it's such a fast moving field. It's so chaotic. You can't really know like what's going to be the next best thing. And instead you should just work on what you think is interesting, because that's where you're going to be able to, you as an individual is going to be able to help the most.
Yeah, I think that resonates a ton, especially for people who already are working, like going, like thinking about like the problems you want to solve and the impact you want to have is like a much better framing, because at the end of the day, it's like tools. Like it's a tool to solve a problem and not the problem itself.
I think I agree. And the researchers who I have like, looked up to the most and who have like, who have been the most inspired by have been people who have just, had some like interesting question that is burning in their head that they want to solve. And sometimes that results in like super interesting things where they discover something that's wildly impactful. And sometimes it doesn't, but either way they keep pursuing it. And that's, I think, what's made them do their best work.
Interesting. And I think one other question I had is like, what are some NLP applications that you're excited to see being built on like in the next like few years? Like, are there things that you want to see happen? Like,
yeah, totally. in the next few years, the things I'm really excited about is like, the first thing I'm really excited about is just like using large language models to solve all these pretty, I'd say like almost boring problems. Like there's a lot of stuff currently that is done with much simpler and less powerful technologies that can be done really well with large language models. And that's stuff like classification or entity extraction or like, error correction. These things that are currently done out there with other approaches or by people who could be doing something much more useful with their time. So there's all these like boring, benign problems that I want to solve. The things that I think language models will do in the next little bit that I think are exciting and people will see the impact of, is I really think with the proliferation of access to language models, we'll start having language as the default interface for computing. Mm-hmm. Like that's the real thing that I want to get done. Is we spend our whole lives developing language as the primary tool of communication, and then you sit in front of a computer and you use almost none of it, and that's really weird to me. Like you should use the tool you've developed to communicate with people, to communicate to a machine, and that's like Cohere's. This is not me talking about AGI or something like that. Like Cohere is not an AGI company. We're not trying to build that. We're just trying to build language as a thing you can use with a computer, and I think we can get there without AGI, with the stuff that we have now, just properly developed and deployed.
Yeah, no, I think that's fascinating. There also there's so much low hanging fruit. Like how many people have had a good experience with a chatbot? Like
nobody. Yeah, and that's because they're not useful yet. But I think when they are powered by large language models, they will be useful. And you'll be able to ask a question and get a nuanced answer and follow up on the next question and do something that actually saves you time and doesn't leave you frustrated. And one of the things that I think motivated me in all this is when Google Home came out, I was excited about it, and I bought 3 of them. I like 3 of the little mini ones. I was like, oh, this is so cool. I'm gonna ask questions, and the first few weeks I would ask them, I would use it, and then for a few weeks after that, I realized I was kind of only using it as a joke. I would only ask it dumb things, and it would tell me the Wikipedia article. And then even after that just kind of got annoying. And then I would only ask it the weather, and then it would trigger so often randomly that I just unplugged them all. And that the promise of language as an interface really didn't pan out with that generation, but I think it will now with transformers and network-based APIs to get access to them.
No, I think 100%, because I think even as we think about education as CoRise, there are so many interesting applications on most people ask the same questions, right? It's if you take the intro CS class at Stanford or Berkeley, every year you're kind of getting similar questions, but you're recreating that knowledge again and again. And how do you bring the cost of education down using NLP is a fascinating problem for us. So we have a bunch of audience questions. Cool. Someone asked how is using Cohere's API different from using AutoML?
AutoML, yeah. So Cohere's API. So one of the things, you don't need a data set to use Cohere's API. Cohere API gives you access to a pre-trained large generative model and a pre-trained embedding model. And so we have co.generate, co.embed, and then we have this co.classify thing, which is built on top of those 2 models that can classify stuff. And none of those need data sets to work. So you can come up and write a prompt and start using starting to get actionable stuff out of the generate model without data, and you can start embedding things and clustering them or semantically matching them with the embedding model without fine tuning. And the same, you can also use classification for the co.classify for that as well. You then can go to Cohere and upload a data set and fine tune on whatever task you're doing and do better on all those tasks as a result of fine tuning. And that's similar to an AutoML thing. You've uploaded a data set, you've gotten a model. The difference is that this is a little more tailored and focused on this specific application of taking a language model, specifying it a task, and now it's serving and running in our backend, and you can just be making requests to that the way you were making requests to the baseline model. So there's certainly overlaps, but ours is a little more tailored at this. Start with no data, use the model, fine tune in the same workflow. Now you have a better model.
Awesome. There's one other question. Ishan had this question around like, how do you incorporate like human feedback back into the models? Like,
Yeah. So currently our models, like when they're done training and then when they're done fine tuning, they don't take human feedback. So our models are not like sitting and look, taking the stuff that's coming into the API and refine tuning on that. We have, like, if you're using one of our models, because fine tuning is a programmatic thing that can be launched, you can, create a fine tune that does something, collect feedback on how well it's doing, save examples of when it does really poorly, save examples of when it does really well, and then launch another fine tune job on that. And then in that way, integrate the human feedback from your application. But that doesn't happen by default. That's not we're not training on the stuff that's coming into the model.
Yeah. And then one other question was, what are some opportunities that are possible, like job opportunities in NLP that this person said, like, there are not that many jobs in NLP in like Nigeria. So like, how should they think about it?
Yeah, that's a great question. Yeah, I mean, I think that's a broader question about computer science and the functioning of the tech economy as a whole, which is that there's like tons of really talented, amazing people who are in places where finding a job is difficult. And one of the things that has been good about the pandemic is people have gotten a lot more comfortable with remote work. So I think the opportunities are certainly opening up. For somebody who's working in NLP currently and in a place like Nigeria where there isn't like a Google office down the street, or they don't know somebody who works at a tech company, you can give them a reference. I think the thing to do would be to apply to companies, like, not restrict yourself to one time zone or to one continent even, and to apply around the world. And there's tons of smaller companies now that are really looking for a bunch of people, and are open to remote work. And then from there, use that first foothold to get to wherever else you want to go. So we recently launched, Cohere recently launched a not-for-profit subsidiary called 4AI, which is being run by Sarah Hooker. And that's a distributed research group for people from around the world who want to like get mentorship and learn how to do research in machine learning. We're taking applications for that. So if that's the thing you want to apply for, please do. But one of the whole reasons for launching that was us realizing, like, man, there's so much good talent all around the world, in particular in Africa, that doesn't have access to paths into the traditional ML career. And that was one of the motivations for relaunching 4AI. So yeah, it certainly is a problem. And
No, I think, and like the point around like leveraging startups that are generally like a bit more like remote friendly is like pretty interesting.
Yeah. I think I think one of the things that's rough with the tech industry is that it's a lot more network based than it looks like from the outside. Like, because there's this whole, it's like, oh, you can go to Google and you do the leak code interview and like whatever, you get it. But so it seems like you need to know somebody who knows somebody to get a job. And that's what I find is not as true as it looks from the outside. So like going to MIT is still really great for you in your career because you meet somebody who knows somebody. And that means it's difficult for people to break in, who are in places that are underserved. But the talent in those places is obvious. And to me as an employer, like some of the people we've pulled from around the world are just amazing. And we're like lucky to have figured out how to get in contact with them. But if you're in one of those places, like, you just have to, I think, work out every little advancement you can by first getting into a smaller place and then working with that and building up the network that way. Now, that's not to say I think it's really difficult, but I think it can be done. And I've seen some people do it successfully.
Yeah, no, I think that's perfect. One question is, like, Abian mentioned that he's a fan of your soft nearest neighbor loss paper from a while back. He was wondering, how do you fine tune large language models for different demographics? Like how the example is like how a millennials would converse versus someone that's like not a millennial.
A millennial. Oh, cool. First of all, thanks for the soft nearest neighbors paper. I think I was talking earlier about just like working on stuff that was interesting. And that's a paper that's really just like, Jeff told me this loss function one day, and I was like, that's a really cool loss function. I wonder what I can do with it. And so that paper is just like a grab bag of random things. And none of them turned out to be very impactful, but they're all very fun. So I was like, thank you for reading that paper. in terms of how do you fine tune for different demographics, one of the things that's true about language models and that, we've noticed is that every group of people people have their own idiolects, and there's really different styles of speaking in different communities. And taking one model that has been trained on one style of language and applying it to another does not work nearly as well as taking one that's from that same distribution. But the way you tune that is, again, just by fine tuning. So you start with the biggest, broadest, trained on everything, and then you fine tune it on a specific idiolect, and that sees improvements. So the same way as you train, just now trained on a smaller set of data.
Yeah. I think we have a lot of interesting questions. So Tim had this question around as you're thinking about basically preventing the model from generating hate speech, how do you think about the trade-off between fine-tuning versus changing the pre-training data set itself?
Yeah, so we focus on the pre-training data set for now. And that's because it's a convenient way of doing it. We can that we know hey, we just removed that stuff from the data set. It doesn't know that, but that has its own problems. One of the problems that has is erasure. If you go out and you try to remove things that are talking about racism within America, you're trying to remove racist text, you'll end up removing all of the great articles that people have talked about critiquing or proposing solutions or trying to make stuff better. So there's this line, you want to take out bad stuff, but if you do that, you're also going to erase the whole conversation, and that's not great either. So we've tried to have better ways of fine tuning, more subtle filtration techniques. That was the whole likelihood filtration thing. Again, the difference between fine tuning and a model and training it from scratch, when we did that, was pretty similar actually. We found that we could fine tune, and that was promising. And that means we can take a model and just keep updating it as new stuff comes in and as people identify new things that should be removed or added in. But the problem with looking at it only from a data filtration technique is that you get this erasure problem. So other people have been looking into actually training models on the entire unfiltered data set, but with tags. That's called controllable generation. And that's a pretty promising direction. I think people will be working on that in the next little bit, and I'll be paying attention to that literature.
And then Piyush had this question around the latencies you see on Cohere for solving certain problems. I think it was just an open question around latency bumps, I think.
Yeah, I mean, so we offer a few different model sizes, and that's because we know that there are some things where latency is really important and some things where it's not. It's true that the models we serve are really big, so there's a whole lot of computation that needs to get done, and that's where the latency comes from. We're interested in improving that, and we improve that by increasing model performance so that we can have smaller models doing just as good a job. We worked on that by other techniques pruning and sparsity and quantization and other things. But the reason why we have multiple models is that we know there are some things where accuracy is more important and some things where latency is. And that's the trade-off you have really with the scale of model.
Yeah. And then I think there was one question around this is a fun question, which is, what's the difference between emotion classification and sentiment analysis? And
I mean, from a scientific ML point of view, those are the same. But that's me saying all classification is all fine-tuned classification is the same. You have a data set, you have some labels, you learn a function that predicts the label from the class from the input data. So whether or not that's sentiment analysis or emotional classification, I think those are just words. I mean, you could give me a data set where I would say these are two very different problems. One of them, if it was just predicting this is a positive or a neutral sentiment, that's a pretty, or a negative sentiment, that's a pretty tangible, well-scoped thing. If you had another data set where every class, you had 1 million classes, and every class was, well, this person is envious with a twinge of self-loathing or something like that, that could become a much more complicated problem. But those are both just classification problems, and so I would say they're the same.
Yeah, I think I would add something similar. It might be related to one of the projects that we have in the course, in the NLP course, is I think if you look at things like therapy, like just knowing positive or negative sentiment is like a very superficial signal. So like being able to like think about like how you are like classifying a chat conversation into like much more granular emotions is like a potentially interesting task. But as Nick mentioned, it's like ultimately there's that classification problems.
Yeah.
Someone had this question on how do you pre-train? Does Cohere allow you to pre-train a model on a different domain? So say like legal or retail or something like that.
Pre-train is maybe an interesting question. Like there's no way for you to take a model that has been trained on nothing and train it just on your data set. There's only the fine tuning, but that is almost always better. Like one of the things about language is that even when you have a huge data set, the space of language is so massive that you're always going to be better off taking a general pre-trained model and fine tuning it than you would on training the thing from scratch on your data set. So no, we don't offer that, but there's no reason to really. Yeah.
I got that sentiment. I think in general, like basically like how one can think about it is like your general language constructs can just come from the larger model, and then you can like create the specificity of like the domain and like this fine tuning.
Yeah, exactly.
Yeah, and I think that's pretty much. I think I've covered most of them. One question that ABN had a follow-up to the question around like fine-tuning for different age groups is, could that be done? So this was the question around how do millennials use language versus how do some like more older generation, like could it be done using ensembling? And is there a person that like in some sense you're like not trying to classify people on like cuts of age, you're trying to figure out like what their speaking style is. So it is like, can that be done with like just a single model?
Is the question, can we have a model that reflects the true massively diverse styles of language without training one specific model on one specific dialect? Is that the question?
Pretty much, I think.
Yes. yes, we can. Yes. It's fine. It works out fine. You can take the model, and if you put in a paragraph that's written in like medical text, you'll get more medical text out. And if you put a model in that's written in like elite speak or gamer slang, you'll get more of that out. And that's because the capacity of these models is really huge, and so they can learn lots of different things. But again, fine tuning is you're always going to get a better thing with fine tuning. But we don't train a model. We don't ensemble a model where each model is trained on its own like style. And then that's because those styles like medical text or legal text or gamer speech, like there's not clear delineations between those. Like that's all just different areas of this huge true distribution. And so we train one model on that distribution.
Awesome. I think we're right on time. And if there are more questions, please follow up with me on like Twitter, or you can send me an email at like Sourabh@CoRise, and I'll route them to Nick and get you answers.
Great.
Awesome.
Thank you so much for the conversation. Yeah, great questions.
Super fun. Thank you. Bye.
Okay, talk to you later. Bye.